Okay, let's close out this section now by doing an example with the normal and tangential components of acceleration and finding them. Okay, so let's say we have a particle that's moving along this trajectory here, cosine t, sine t, t, right? And let's find the two components of acceleration. So we have to start by finding one or the other, the tangential or the normal. The tangential is usually an easier one to get at, so let's go ahead and start with that. So remember, AT is given by r prime dot r double prime over the magnitude of r prime. Okay? So once we have that, now we just have to compute r prime, compute r double prime, and take their dot product, and then take the magnitude of r prime. So let's find out what is r prime of t. Well, this is just going to be minus sine t, t, 1. Right? And let's take the derivative of that and get r double prime. R double prime of t is minus cosine t minus sine t, 0. All right. So if we're going to get AT, we need to do the dot product of these two guys. So let's go ahead and do that now. R prime dot R double prime. So we get negative sine times negative cosine. So sine t, cosine t. All right. And then we have cosine plus cosine t times negative sine t. So minus cosine t sine t. Let's make this s a little more s-like here. Right. And then plus 1 times 0. Well, look what's happened here. We just get 0. So what does that mean? That means that AT itself is 0, right? If the numerator up here is 0, then the whole thing is 0. Well, this actually puts us in a really nice position because since AT is 0, remember the magnitude of A is square root of AT squared plus AN squared. Right? This is why this is a very convenient fact. We plug in the 0, and while we have square root of AN squared, the AN squared, or AN itself, sorry, AN is always a positive quantity, because remember, it's a magnitude of something over a magnitude of something. So that means this is just AN. In other words, the normal component of acceleration is just the magnitude of acceleration in this case. So let's go ahead and find that. So AN is magnitude of A, and that will be the square root of negative cosine squared, so cosine squared t, right, plus negative sine squared, so plus sine squared t, plus 0 squared. So we'll just go ahead and leave that off. Well, sine squared plus cosine squared is 1, square root of 1 is 1, so the normal component of acceleration is just 1. So here are two answers. There's a tangential component, and let's write it on a new line. AN equals 1. So we can put a nice box around it. Okay? So that gives us the normal and tangential components of acceleration. And that's pretty much all there is to it. Sometimes it might involve a little more work for a more complicated position function, but it's usually not too bad at all. Okay? Hope you enjoyed the section. See you in the next one.